So that leads us nicely into particular solutions. So what particular solutions have is an initial condition that we get at the kind of start of the problem. But the first thing we actually want to do is to take the integral of our f prime of x, so the integral of 1 over x squared, which we can rewrite as the integral of x to the negative 2. We've integrated this before, so we know that f of x is equal to negative x to the negative 1 plus some c. Okay, and we could rewrite that as negative 1 over x plus c. Our initial condition tells us that when x is 1, y is 0. So I'm going to write 0 equals negative 1 over 1 plus c. So c is then 1, okay? And our f of x, our particular solution, is negative 1 over x plus 1. So that initial condition tells us exactly what we started with at the beginning rather than just, it could be some constant c. Okay, so it gives us that particular solution that we have. This next one, we actually start with the second derivative, and it gives us an initial condition for the derivative and for the original function. So we're going to have to do a little bit of stepping here. So we're going to start by taking the integral of our second derivative, so 2x plus 3. So our integral is, or our answer is going to be rather, x squared. And remember, when we multiply by the 1/2, that's going to cancel with that 2. And then plus 3x plus c. And that gives us f prime of x since we started with the second derivative. Our initial condition for that was that when x was 2, f prime was 8. So if we do the math, we get that c is equal to negative 2. So that means our first derivative is really x squared plus 3x minus 2. So we're going to take the integral of that. And when we take the integral of that, this becomes 1/3 x cubed plus 3/2 x squared minus 2x plus c. We know my initial condition is that when x is 2,